Okay, today is 15.2. It's solving trig equations. Would you agree that there is an x in the first example there? If you're solving for x, that just means you're trying to get the x alone. We have done this problem before. It's just a circle trig question, and the question really is, what's the angle? You get we already have the side ratios. We just want to know what the angle is. So we're going to make our first triangle where cosine is positive, and our other triangle where the other place where cosine is positive. All students take calc. These two are the two where cosine is positive. Therefore, I'm throwing out these two. Now, you might be thinking, wait a minute, we were doing inverse trig, so you're only allowed to be in the top two. From here to here is where inverse cosine is allowed. This isn't inverse cosine. This is not an inverse cosine question, so we don't have that restriction. So the answers are in two spots, here and here. How many of you drew your triangles in the right quadrants? Okay, good. That's the easy part. Now, actually, what is the angle? It's a little tougher question. Not super hard, though. Adjacent, square root of 3, hypotenuse is 2. That makes that a 1. That means this little angle is across from the 1, and therefore it's a 30-degree angle, but pi over 6 is what you'd be looking for there. Raise your hand if you had pi over 6 for that one. Good. And the other one is a whole bunch of pi over 6s, because, again, I know you might be thinking, didn't we do negative angles here? If it's inverse trig, yes. This isn't inverse trig. So we go all the way around to get to there, and this would be a whole bunch of pi over 6s. Think of it this way. I like to think of it as if it had just finished and gone all the way to 2 pi, that would have been how many pi over 6s? 12. So I back off 1, and it's 11 pi over 6. Raise your hand if you had pi over 6 and 11 pi over 6. Excellent. You're all wrong. I know that's evil. But do you get that this does not say that you're only supposed to give the answers between 0 and 2 pi? Do you get you could keep adding 2 pi forever and get more answers that are right? Get what I'm saying? We could just keep adding 2 pi and you get another answer. Keep adding 2 pi, get another answer. So there's unlimited answers. But we would say that pi over 6 and 11 pi over 6 are two of the answers, but then you'd have to add 2 pi to them an unlimited number of times. So here's the shortcut for saying all the rest of the answers. You can't just say plus 2 pi, because that'll just give you 2 more answers. You know, one for this one and one for that one. But you can say plus 2 pi n, where n is an integer. And if you wrote n is an integer, I would have been okay with that. But here's the shortcut if you want to be extra smart. N is an element of z. Z is the integers. You heard of the big R, stands for real numbers? Well, be introduced to the big Z. You know the big R? All real numbers? This is the big Z. There, big Z. Serious, that's kind of what it looks like. Nah, you just draw Z. But okay, so n is an element of z. That means it's an integer. Why? Because we don't want to multiply by 2 pi times 0.9. We have to limit it to multiples of 2 pi. So multiples like 1 2 pi and 2 2 pi's and 3 2 pi's. And okay, all right. Do you get the only thing that's different than what I told you before is this piece? There's nothing new here really, except for how to say all the rest of the answers in the world. Okay, then here's the next step. This problem is frighteningly similar to the problem you just did, except for it says cosine of 2x. Does that make you think of anything? Yes? The double angle. But if you do it that way, it will be long and painful. You don't want to do it as a double angle. There's a much, much easier way. Here's the easy way. Would you agree it would be a lot easier if I just didn't use 2x and instead used like x? Or couldn't I use any variable I want to? Do you know what I'm doing here? I'm substituting out and not going to use 2x. I'm going to put in a, what's the correct variable for a substitution? The u substitution. Exactly. And do you agree we don't need to do this whole problem over again? We already have the answer. We just did the problem a second ago for u, or in this case x, equals root 3 over 2. I already got the answer. So I'm going to just write what you would have gotten. You would have got u equals pi over 6 plus 2 pi n. And u equals the other answer. 11 pi over 6 plus 2 pi n. But, and it's a big but, the reason we use u substitutions is so that whenever you see a u in the answer, you don't forget to just leave it that way. You have to substitute it back for the thing you swapped out before, because now it's a lot simpler to solve. So what was I substituting? I had a 2x there, so that means I have to make my u's back into 2x's. And then, what was the whole point? What's the goal? What's the direction say? Solve. So you got to get the x alone. So how do you get that x alone? It's really simple. Divide by 2, but these are fractions. It'd be easier to multiply by a half. So multiplying by a half, we'll get the 2 off of there. Multiplying by a half makes that become pi over what? 12. And you have to multiply this by a half too. Might be thinking, but wasn't that just a generic thing we slap on there? Yes, but pi was, or 2 pi was the period before. Do you get we just changed the period by putting in a 2 in there? You get how that changes the period, and therefore we have to apply that little 1/2 to this too. So what does 2 pi n times a half change into? Just pi n, or 1 pi n. Yep. Same thing over here, multiplying everything by a half, a half, a half, and this becomes 11 pi over 12 plus pi n. Oh, and what do I have to clarify about n? N is an element of z. Very good. Okay. That's the new stuff for today. Really, there's just 2 things to it. You got to be able to add plus 2 pi n to acknowledge the fact that there's unlimited answers. Then you have to be able to do a u substitution when they throw in something tricky here. And don't think of it as a, what do you call that? A double angle. It would have worked as a double angle, but as the u substitution, believe me, is way easier. Okay. So now let's do some normal inverse trig again, just to remind you about how those work. So let's try a sine of the arc cosine, which is the inverse cosine, of negative 1/2. That is a pretty normal-ish nested inverse trig question. You'll have to be able to do that too on the little quiz tomorrow. The quiz tomorrow, by the way, to lower your concern but raise it at the same time. Number 1, it does have solving on it. The thing I'm talking about right now today, the thing I'm teaching you today, there's some solving on it. But part B, you will have a partner to work with. So that'll make it easier. All right, that's happening tomorrow. I will not be here, just to clarify. There will be a reserve teacher here, and I've got the test done and I've got the key done, and you're going to be taking the test until about 10 minutes from the end of the hour, and then hand the keys out. Everybody does their own test is an important point, because I know last time we did a group test, you only did 1 test. Everybody does their own test. So if somebody's doing most of the work, well, I guess the other person's just going to have to copy them. I'm just saying, you have to have your own test separately. Okay? Then I'll see your results after the key is handed out. Why aren't I just grading them later? Well, the main thing is, I would not have to wait 12 days to get my results. Okay? So the keys will be handed out, and you'll be grading them in class. And then I am going to tell you ahead of time. I've decided this is going to be in the formative category. Okay, but it will count on this quarter in your grade. Yes. It's a quiz. It's a quiz. This is not nearly as many points as a test. Tests are out of 100 points. This will be a quiz, which means that we will scale it down. It won't be as worth as much as a normal test. But what? It is going in the formative category, yes. Okay, but to make you think, here's a common, really common misconception. The homework doesn't matter. I mean, homework's only 15%. I've had like 3 people this week turn in an assignment, and it's raised their grade for turning in one homework assignment. People just don't get it. They don't get math. 15% means 15% of your grade. That means that it can swing your grade 15%. If I take any one of your grades right now, let's say you're at an 85%. What if I add 15% to it? Would that help? Of course it would. It's huge. So people think somehow that because the 85 is bigger than 15, that 15 doesn't matter. Complete baloney. Turn in a homework assignment. I've had people turning in a homework assignment and achieve the next grade up just from that. Not because they were just like a teeny bit away from it. So don't let the misconception that 15% count category doesn't matter deceive you. Yes? I do drop a homework assignment. One more thing. The tides lab. I'm not going to have time to do it today. So that means it's still going to go in, but it'll go in on the first day back, as in, and it turns out I also want to be comparable to the other teachers. The other teachers are assigning theirs due after break too. So hopefully you're done with it though, so you're not stuck with, oh crap, I got to do this lab over the break. You should be done already. So I just can't get it done today. It'll take too long to grade. So I will take that on the day after break. It's due, but you should be done with it already. All right, hopefully you got this one done by now. You should have made a picture. You need a triangle for every single problem. When you're doing inverse trig, you need to make triangles. Okay, where is the triangle for this one? I would first have rewritten it into cosine of some angle is equal to -1/2, but that's technically not the same thing. Why? Because it doesn't have an inverse. This was an inverse problem, so it has restrictions. Inverse cosine's only allowed from there to there. So that means I have to cross off these 2 spots. Then I have to say to myself, where is cosine negative? Only over here. So I cross off that spot, and there's my triangle, and then cosine is adjacent, -1 over hypotenuse, 2, and that makes this other side square root of 3. That means this must have been a 60, or a pi over 3, and therefore this answer is actually 2 pi over 3. Just wait. You're right. I didn't even need to really figure out 2 pi over 3, but it is. This comes out to 2 pi over 3. What do you mean you didn't have to figure out 2 pi over 3? Because you're going to do sine of it. And that just means refer back to the triangle. What is the sine of it? Sine is opposite over hypotenuse, root 3 over 2. Final answer, root 3 over 2. Raise your hand if you had that one right. Okay, good. Now, imagine for a moment that I had made this problem harder, not exponentially harder, but harder. What little thing could I have thrown in that would have changed this to the next level question? Make it more of an R3. That's more like an R2 nowadays. When you first learned it, it was an R3. Now, we've done it so many times, this is an R2. How do we make it R3 nowadays? Yes, sir? Yes, I could change this to a function you're not used to, like secant. And then if I had done that, I would have just taken my answer and done what? Flipped it. Okay. That would make it a little harder. How do you make it definitely harder? What do you think in the back?
Use a variable.
Use a...
Instead of like what negative 1/2.
Ah, yes, I could have thrown in an x over 2, and then this would have been an x right here instead, and then you would have had to use it. Yep, absolutely. That makes it an order of magnitude harder. How about you? You could have, how about just leave it as sine, because you could still do it with that. Your suggestion of putting a 2 in is exactly what I was thinking. So if I put a 2 in there, I'd like you to think of it as the 2 is out here. I'm going to put it over the dot in the I. So sine of 2, blah, blah, blah. Okay, so how does that change my answer? Can't I just have the same answer? Nope. Because now it's a double angle. as soon as you see something like this, unless you can do a u substitution for it, like I just showed you on that other kind of problem, if you're doing an inverse trig problem with it, I would do, oh, what is sine of 2 theta? What is it? Got it memorized? You'll need it. 2 sine cosine. So really, I just need to know what sine is. Haven't I got a little triangle for that? And I just need to know what cosine is. I got a little triangle for that. Do it. Tell me what the final answer on this one would be if I threw the 2 in. Okay, sine is opposite of hypotenuse, root 3 over 2. And cosine is adjacent over hypotenuse, negative 1 over 2. Multiply it all out. I'll put this 2 as a 2 over 1. You can always do that. Multiply across the top, I get negative 2 root 3 all over 4. And could that simplify? Yeah. 2 root 3 over 4 would simplify to negative root 3 over 2. Which is kind of weird. That combination keeps coming up. But it's fine. There's only certain combos that work nicely. All right. Let's see if you can do another one like that. Actually, let's make it. I better do sine, because sine of 2 theta is a lot easier to work with than cosine of 2 theta. Although it's not that hard. Here. Solve that one. I'll pause for a second while I give that a try. Okay, so we're getting down to the right triangle here, and we've got it to 45, but we can't say 45. We say what again? Pi over 4. Why isn't the answer just pi over 4? Oh, it's a lot more complicated than that. Because it's sine of 2 whatever. So that means we don't just say the answer of pi over 4. And the worst mistake you could make is think it was just pi over 4 and then say 2 times pi over 4. No. Because we got to rewrite this as 2 sine theta cosine theta. So in this case, 2, and then what's sine theta? From that triangle over there, what's sine theta? 1 over root 2. What's cosine theta? 1 over root 2. So then this becomes 2 on the top over, oh, so many people down their test wrote root 2 on the bottom. You're multiplying the root 2s. Makes root 4, which is 2. So it's equal to 1. And could you have actually done it where this was sine of 2 times 45, which makes sine of 90? Isn't sine of 90 equal to 1? Yeah, you actually could have done that. But the way we'll set them up, you probably wouldn't be able to do that because it won't come out so nice. All right, so there's just a reminder on inverse trig. I need you to do another solving with me. So let's get to the actual homework for today. Everybody find assignment day 1, solving trig, right here. And I'm going to show you a few tips and kind of give you a guide through this. First of all, on number 2, that one will be a simple one with the u substitution. So right away, you might want to go like this. Let u equal 3x. To remind yourself, you're going to do a u substitution there. You'll do the same exact thing on 3. On 4, something changed and got weirder. What was it? It was cosecant. So yeah, you still do a u substitution, let u equal 4x, but you also change it from cosecant of u equals negative 1 to flip it. What's the flip of cosecant? Sine u equals negative 1, but then I got to take negative 1 over 1 and flip that, but that doesn't actually change, does it? When you take negative 1 over 1 and you flip it, it's now still negative 1 over 1. It's a little weird, isn't it? You flip the one, but it's like you didn't flip the other, but you did flip it. It's just the same thing. Okay, so now there's your new problem. And you find the answer. When you're all done, you'll have u equals whatever. Don't forget to put plus what? 2 pi n. Okay? And then, are you done? No. You'll have, let's say that you came out with u equals, well, can you do this one in your head? I can. Sine's -1. That means y. Sine is y, right? Where's y -1? Where's y -1? Down here, right? 3 pi over 2. Are we doing inverse trig? No. So it's 3 pi over 2. If we were doing inverse trig, it would be negative pi over 2, but we're not doing inverse trig right now. So it's 3 pi over 2. So the answer was u is equal to 3 pi over 2. Okay. Was there another place sine was -1? No. Sine's -1 only in one spot. The only place where y is -1 is there. So it's only one answer. So then I say plus 2 pi n. But then I'll let you do the last part. What do we swap out for u? 4x. So then you're going to put in a 4x right here, and you will solve it from there. I'd write that down if I were you. I didn't see you move your hand the whole time, so I'd write this down. Question? Oh, yes, it's true. At the very end, you should say n is an element of z. I'm pretty sure we're not going to mark anybody's test wrong for not saying that, but it's good for you to get used to that notation. Okay. Number 7 is it's got a cotangent in it, so I don't like cotangent. Can I just switch it? Yeah, I can switch cotangent for tangent, but then I got to take my sides and do what to them? Flip them. All right. And I don't want to use a 2x either. You get how you can get kind of fussy? Like, I don't want to use 2x. I'm not going to. I'm going to put in a what? A u. And then later, I'm going to say, since I said let u equals 2x. At the end, though, when I get my answer, u equals whatever, I got to swap the 2x back in. All right. So now, this page is also very similar, and it seems really scary because when you get to like things like this, just swap it out and say let u equal all that. And then at the end, you'll just have to add pi over 3 and divide by 2, and you'll have x alone. Okay, this one's, hint, hint, there's going to be a square root of a variable involved. What does that bring in? Plus and minus. You might want to give yourself that little hint off to the side on that one. When you square root a variable, you get a plus and a minus. Okay, now, this is a little bit longish, but on the plus side, this is the only assignment you have for tomorrow also. This is a combo assignment. Today's and tomorrow's all in one. If you just get it all done tonight, you can walk out of here with no homework when you're done with your quiz. But I think more realistically, some of you are going to get some of it done tonight, and you better, because this stuff's on the quiz tomorrow, and you don't want to be the lame partner to get because you didn't do any practice. Okay, because some of you guys are going to be, well, you're going to get a partner for tomorrow's quiz. So you don't want to be the person who's the weak link in the group. So get your homework done. You don't have to get it all done tonight, but get a bunch of it done tonight. The assignment goes up through this one right here. And on this one, I want to give you a hint. A hint for number 21 is divide, write this down, both sides by cosine. If you can get all the way through that problem, that's good enough. Yes, sir. Ignore the circles, really. Just do all the problems up through 21 on this assignment. That's it. Stop at 21. Okay? In general, it doesn't matter if a circle is dark or light. If it's circled, it implies the teacher looked through and made sure it was reasonable. Some of them are really, really, really challenging. Okay. So that's basically all I'm asking you to do is stretch out today's assignment. Would make it, it's a little longer than I would normally make it, but you just have to, you can finish it tomorrow after your quiz. The quiz tomorrow's only got eight questions on it, and several of them are 1-minute questions. So a few of them are challenging, but all right, some tips on that quiz for tomorrow. On one of the quiz questions, I thought you could factor it. And solve it that way. So I said, if you can factor, what's the answer to that? You should. But unfortunately, you can't on that problem. So I'm giving you a new hint for that problem. Would you agree that sine squared plus cosine squared is equal to 1? So therefore, what's sine squared equal to? 1 minus cosine. What's cosine squared equal to? 1 minus sine. And what's sine squared plus cosine squared? Okay. You're going to find those in that problem, and hopefully you'll be able to figure out, oh, we can just replace this with this. Okay, so that's your hint for that problem. And also, one of the questions asks you to find all 6 answers. I am not expecting you to do that at this point. I'm expecting you to just say plus 2 pi n, or if you had to, at the end divide by something or multiply by 1/2, it might be plus 2 pi n over 2, and simplify that. Okay, so if you just say plus 2 pi n after your answers, I'm good enough with that. I don't feel like you've learned enough to be able to handle giving 6 different variants of the answers. You just have to give one of the 2 answers you normally get, and then say plus 2 pi n, or plus 2 pi n divided by 2, or whatever you have to divide by. Okay, so there we go. That should get you through tomorrow's quiz. And then the last thought is, I think I told you this already, we do not have time to get the TIDES lab in today, so we will do that the day after break, and it will count on 3rd quarter as a homework assignment. And it will not be the one that's thrown out if it's the lowest, because I have to do that on Monday. So I'll be throwing out the lowest assignment you have on Monday. Last thought, I want to give you your tests back just before you walk out the door. So you're going to take a look at these, and then you're going to hand it back to me as you walk out the door. That's all I got for you for today.